our topic is Docker, and we are planning to take a basic, what's the basic of Docker, what's Docker and the basic of Docker. We are not going as a deep dive, so we are planning only about Docker, and we will have a quick demo and we have a Q&A session. This is how we planning for. So in between, if anyone have any doubts, you are free to ask. We can go with the discussions. So let us start. Docker, it's a, when we are talking about Docker, we should I think we should start with how Docker came or why Docker. So in traditional time or traditional software life cycle, there is a time when a developer has to code on his laptop, and once everything is done, he will be sending the code to the operations guys or the DevOps guys to serve it. So what happened is when the IT or operations guys serves it, there was so many issues. So when the operations guys came back to the developers, the developers used to say it is properly running on our system, why it is not running on servers. So that was the issue, or that was the thing how Docker came to the page. So as a solution for that, Docker came in. So Docker is a kind of a portable thing which can be taken from the developers to the directly to the servers. So as you know, the main reason for that issue is developers knowingly or unknowingly install or make a environment for the project to run. They will be installing libraries, packages, what all things it should be necessary for a project to run. They will be installing that in their system, and that project is working on their system. But when it comes to the server side, maybe they will be missing some libraries, they will be missing some packages. So there can be a issue for not working that code properly in the server side. So when Docker came in, what happened is developers can be working on the same code, and that code can be shipped to the server directly. So both developers and the DevOps guys are in same page. So that's the main thing, or that's the main reason Docker came to the show. So before Docker, it was happening a single system. When we take from the developers to the production team or the server team, there are so many issues. So that's the main reason why the Docker came in. Yeah. So if he's talking about benefits of Docker, is the main thing is portability. As I said, so it can be ported to anywhere, or the code or the application as a stack with all the libraries needed or the packages needed can be ported to anywhere, and it can be run on anything. So the first benefit is portability, and let's say we can take another side too. If it is running on my system, I need 100 systems to be run on the same. So we can take it or ship it and run it on another systems, many systems as we want. So that's the first main benefits of Docker. It is portability. Second thing is performance. If you are talking about performance, the thing is if you are running a virtual machine, we are running OS in the virtual machine. We, as you know, in our systems we had many, unwanted things. I won't be saying unwanted things, but it is not necessary for development, or it is not necessary for a particular application to run. There are so many things. So when the Docker came, or the Docker needs to be light. So we are building, or the Docker built in a way that it take only what it needs. So of course, when the when the code base, or when the OS become lighter and lighter, it it gives a huge performance difference for the application. So that's the second thing, and isolation is the third thing. Every application in the system can be isolated, because if you are running a Docker container, it contains the OS as well as the application environment as well as the code. So if you are running multiple applications in our system, it can be run as isolated. Each can be independent. It need not be connecting with each other. They can be connected, but if you are running, we need to be independent, it can be run independently, and it's totally isolated. And fourth thing is scalability. The thing is, as now modern IT industry, we had trillions of users, and the scalability is one of the main thing we need to be implemented in any kind of applications. We have to scale at any point of time. We should be able to scale at any point of time. So if you are running a application in Docker, since it is portable and it is isolated, it is very easy to scale, because there are two kind of scales, scale up and scale vertical and horizontal scaling. Because if we need to run 5 Docker containers at a time, or a Docker container with more resources at that time, that can be, we can do that at a ease on click. So it is scalable. That is a fourth benefits of Docker. So the next thing is Docker images. There are two components, or two stages for Docker. First thing is Docker image, and second thing is Docker container. Image is nothing but a stack which contains code and instructions for the Docker container to run. So as an image, the first stage of the Docker is an image. We have to build our image with all the code as well as the instructions to build the container, or to build our application as it is. The next stage is container. So from the image, we are making the image to a executable thing. That is the container. So the container contains all our stuff, all our stack, all our from OS to the application environment, everything will be running on a system alike. That is a container. So first component or first stage is image, then to container. And we have added some of the basic commands for images, to list, to pull, those kind of. We are not going deep into it. We will be going with all this, we will be taking continuous sessions on each one. But today we are just moving to a high level thing of Docker, basics of Docker. So second thing is container. Container is a standard unit of software, like it's a standalone application stack which includes OS as well as the application environment. So it is an executable thing. We can say that the second stage of Docker. And third is Docker file. As I said, Docker have two stages. One is Docker image and second is Docker container. And Docker file is nothing but a set of instructions or a set of commands to build an image. So basically we can say in three stages: Docker file, Docker images and Docker container. From the Docker file, it contains the commands or instructions to how the image should be, what all things should be in an image. So that is Docker file. From the Docker file, we are building the image, and from the image we are running the container as a independent application stack. So Docker file, nothing but it's a standalone, or it's a script or a bundle of commands to which or to how the image should be formed or built. That's only Docker file. These are the some instructions used for Docker file. I think we need a separate session for Docker file, because it is a huge area we have to cover with the instructions. And Sanjay, I think Sanjay will be more. We can continue this session with each stack, and we can continue one session separately for Docker file. For as a basic, we have to think that Docker file is a standalone instructions of script of instructions of bundle of commands from which the image is built. Okay. And the next part will be taking a demo to show how we can work with Docker. So I am pretty sure all of you are so familiar with Docker, but we can see how we can use Docker in daily. The Binoop will be taking. Binoop.
So hi guys. So as Bibin mentioned, so you need to understand like how the Docker works actually. So the Docker works based on a concept of virtualization. So basically, you might have worked with a dual kind of a system wherein you support dual OS support. Like on a Windows machine, you can install a Ubuntu machine. You might have worked on it. Certain people might have worked on this particular stuff. So basically, this is the concept of Docker as well. So as Bibin mentioned, Docker was brought in to eradicate all the dependencies that are required during a development phase or while going to a production phase. Since let's say like our development usually takes place in a Windows environment or in a Linux environment, and mostly the deployment, what happens, it takes place mostly in Ubuntu servers, or we go for Windows servers or anything related to that. So working with two different environments causes a lot of dependencies. To eradicate this, the Docker was brought in. As I mentioned, Docker is work based on a concept of virtualization, which is basically on a Windows machine or on your host machine, with whatever machine that you're working on, we install a separate OS instance on top of our application. So basically, that's how our Docker concept is working. So basically, this works on, as Bibin mentioned, it works on Docker images. So I'll show an example. This is a basic node application. So I'm going with an example of a node application. This is very similar to the tech stack that you are working. Maybe you guys might be working in PHP, or you guys might be working on a .NET project. The entire working concept would be the same. So basically, we have something called as package.json, which is very similar to what is composer.json in PHP, and some nugget in .NET, as well as package.json in JavaScript applications. So basically, as a package.json mentions, we derive all the dependencies related to this particular application. So as a standalone, I can run this application as follows. basically I can run my basic command and start an application. What this will create is like, currently my application is running on my machine, on my local machine, which is exposed on a port 3000, my application is running. So what we are going to do is right now, we're going to create a Docker based image. So as Bibin mentioned, we have something called as Docker file, wherein these are the set of instructions which are required to create an image. I'll go line by line, like what are these images and what are the commands are used for. So basically, as you can understand, the Docker works based on any images. So all the images like related to, as I mentioned, a Docker image is based on OS level. So let's say like I want to build a machine which is on an Ubuntu software, and I need to install certain software that are required for my application to run. For PHP, I need an Apache server, I need a database. For Node, I use a Node.js environment wherein I have certain NPM packages. For .NET, we need Nugget related stuffs and all those particular stuffs. So over here, we can find I am using a particular library called Node 18 points. This is a library, not a library. This is called an image that is already available for us to work on top of it. So let me just search this thing for you guys, so it will be a better understanding for you guys. So very similar to GitHub, we have something called as Docker Hub. So basically, as you understand, what is GitHub used for? Can you just give me an example, like what is GitHub used for? It is a repository for all the applications. So you have you will find a Laravel application that is already pre-built, and based on that, you will be working on top of that, right? A Node application similar to that, we will be working on that particular stuff. Similar to that, we will be having different types of images. So I want to run a Node application right now. So already, since this being an open source, I can find like basically when I search for any Node image, I can find a Docker official image wherein I can build my application on top of this particular image. So over here you can find different types of tags. This is very similar to GitHub. Like you will have multiple tags versions. You will be keeping different versions, right? Very similar to that. We will be having something called as on this tag level also for different images as well. Over here you can see like 20 Alpine, there is 20, 19, 18. All these are versions of Node. Every individual versions of Node. Like if my application wants to run on a Node 20, I need to pull in the Node 20 version. Right now my stable version is Node 18. So what I've used is like I want to use a Node environment which uses an 18 version 14.0. So that's why I'm using this particular command. So basically from Docker Hub, what this particular command will be doing is download this particular package. Entire package of 18 version, it will be downloaded over there. The next command what you see over here is called work directory. This is very similar to creating a folder in your host machine. So basically what I am doing is like I will be downloading an image from the server. On that image I will be creating a new directory app. Inside that particular Ubuntu image I will be creating a work directory called app. That is this particular command for. The next command is basically what I am doing is like I am copying my, as I mentioned, the packages and whatever I mentioned, right? That is in my host machine. So basically what I need to do is like I need to copy this dependency package to my Ubuntu image. That is the command that you find over here, which is called copy. Basically it does that. And the next command what you see is basically installing that package. So as I mentioned, my application works on my host machine. I will be running this command to download all the dependencies. But in the image I need to run this particular activity. So that's why I'm running this particular command, like mentioning run npm install. So basically what this does is like it downloads the entire packages, all the details specific to that particular thing. Over here the next line is basically copy ... This is basically copying my entire source code from my host machine to the Docker image part. So basically this needs to run because I need the source code in my Docker image for the application to run. So basically what I need to do is like I copy this from one place to the other place, to the image part. And the next thing is, this is related to specific to environment. Basically I am creating an environment file which has certain configuration. So basically I need to do this particular thing, basically copy that particular part. And the final part is like since as I mentioned my application runs as my host machine in port 3000. Okay, so specifically as I mentioned, this will be running on a new Docker, on a new OS. I need to expose that particular port. Basically export in the sense I need to access it. Like once my application is running on another Ubuntu machine, I need to know like how I should be able to access this particular thing. So that's why we are exposing a port 3000, wherein like any request that is coming in, it will be sent to this particular 3000 port on the Ubuntu machine. So it will listen to it and it will serve the results for us. So, and the final command is to start my application. So basically this npm start for PHP is PHP artisan serve .NET something .NET restore or something. I'm not sure, pretty sure on that particular thing. So as I mentioned, this is called as Docker file. As Bibin mentioned, this is the entry point where we will define like what should our application be handling. Okay, so let's run this particular thing. So basically I'll be running. So the basic command for first we need to create with the Docker file, we need to create our own image. Okay, that is the first thing that has to be done. So basically the command that is used is docker build -t. -t is for tagging, like create a tag for that particular image, whatever I'm creating. So right now I'm creating something called as node app. This can be anything, like it's leveraged to you. Whatever application name that you want to choose, you can choose it. Right now I'm using node app, and basically I'm putting a dot operator like to execute where the Docker file is, to identify where the Docker file is. In case if the Docker file is placed in some other folder, it will be slash, I'll be mentioning that particular file. So basically when I run this command, you can see like the first thing, it will be downloading that particular image for me. Like it will take docker.io, from that they will download the first image will be downloaded. On the second step, you will see like there will be a new work directory that will be created. On the third part, it will be copying this particular thing. Fourth thing, it will install my particular package over there, and basically my image will be created. So to list down my image, there is a command called docker image ls, wherein it will show the image that has been created. Okay. As I explained already, there is an application that is running on my host machine, which is running on localhost 3000. Okay. So right now I will run this particular application on port 4000 on my local machine. Even then the application will be accessed. So basically the command for running that particular thing is docker run -it. IT is a command for an interactive shell. And basically I need to expose a port, like from which port this particular thing should be accessed. So from my host machine, I will mention like I need to access it from port 4000. Now whatever request that is coming on port 4000, it should be redirected to the 3000 port on the Docker image. That is what you should mention on the second part, which is basically the 3000 part. And finally, I need to mention what image it has to use. Basically, I am created that node app image, so it will create to this particular thing. On entering, basically it will start my mission. Okay. So what happens is like, now there is an application on my which is running on local 4000. Now I can create. So basically you can see like there are two applications that is running. One is running on my host machine, the other is running on my Docker instance. So basically, so based on one image, I can create multiple images. Right now I have run this application on 4000. What the benefit of Docker is like, there is a concept of scalability. In my machine, let's say like if I'm getting 100 requests and my application can serve only 100 requests, I need to spin up a new server for creating a new application. But that is the general concept, like we need to create a new server or we need to deploy a new code and assign a new port to it. But over this concept, basically I have an image already available for me. I can use that to run a new Docker instance. I can use the same command. I'll run this particular thing on port 6000 for you guys, and I'll push in same 3000 port and the image that has to be run. So this will also spin up a new server for me, wherein I can access the new application on localhost 6000. I think some error is there. Sorry. So right now spin up is Ebin, are you? Hello, Ebin. So basically, as you can see, right now the server is running on localhost 5000. Okay. So this is one of the concept of scalability. So right now, what I did is like I did something called as volume mount over here. So basically, let's say like if I want to make some changes to my application, let me just edit a particular, create a new response for this particular thing, wherein I am passing a user data. So basically, I'll remove it as so basically what happens right now is like on localhost 4000, when I create a new user, it will create a new autoload records. A small thing has to be done, just give me a second. So we are facing some issue related to the application part. So basically the concept is like there is a concept of scalability wherein like I can with a single image I can spin up multiple servers on my same mission. So this is called as vertical scaling. So basically how many number of requests that is coming in, I can place my request based on that particular part. So there is something called as orchestration wherein like let's say we use load balancer, right? So once a certain set of requests comes in and we have a threshold limit, like once the CPU limit crosses around like 60%, what we mention is like we automate our system to create a new Docker image and create a new application and assign it to a specific port. So what this will create is like when an incoming traffic is coming in, when the load is more than 60% or something, the request will be transferred to the other servers. So based on this, we can simultaneously maintain the downtime of an application. Like there will be 99.99% is what they are claiming, and it's based on multiple type of orchestration method that we include into our application. Okay, so this is an overall demo of this particular what is Dockerfile. As Bipin mentioned, this is a very vast topic and we need to take it specific to technology wise, and we will be creating a new session for each application. We will be creating like as I mentioned, like right now this is for Node. So similar to PHP, .NET, we are created separate Docker base for individual programming language, and we will be creating a separate session specific to this particular thing, wherein the Docker will be explained specific to that particular programming language, and along with the base methodologies what we are going to follow for that specific platform.